All right, problem number 6, if you watched the last video, you know is true. But why is it true? And this is important. Our definition of what a subset is, let's just write this out here. We can say that A is a subset of B if and only if, we can write if and only if, for all elements X that are members of A, X is also a member of B. And I haven't introduced this notation yet, but that's all that means, right? This is how you read it all. Starting here, this is the symbol for subset, which I have pointed out before. So some set A is a subset of B if and only if, shorthand notation, for all, that's all this little upside down A means, for all X that are members of A, and A is this right here. So we're saying for every single item inside of A, we want to check to make sure that that item is a member of B. So we need to just check one by one. Is A in B? Yes. Is B in B? Yes. Is C in B? Yes. But then we do the same thing to determine whether or not B is a subset of A. And again, we look at every single member of B. Is C inside of A? Yes. Is A inside of A? Yes. Is A inside of A? Yes. B is inside of A. So yes, it is true that A is a subset of B, and it is true that B is a subset of A. And we had talked about previously in an earlier video, but that just means that these two things are equal. They both have the same cardinality. They are both equal to each other. Which is essentially why when we see that, we have an A and an A, we can kind of just ignore it. Because when we look at these two items together, they are subsets of each other, so they must be equal. And this is all based on our definition of what it means to be a subset and what it means to be equal.